Everyone knows India invented zero, but does that mean zero didn't exist before? Not exactly. Zero in some form was already around, as a placeholder or as a blank space, but nobody had treated it as a full number. Think about gravity. People always knew that if you throw something up, it falls down. But nobody understood why until Newton explained it with math. That doesn't mean gravity didn't exist before. It just means no one had formalized the rules. Similarly, zero had been used informally as a space or a marker. But in India, mathematicians transformed zero into a number with rules of calculation. And that changed the world. Before zero became a number, civilization had clumsy ways of writing and calculating. For example, Romans wrote 204 as CCIV. Other civilizations left blank spaces. So 204 could look like 2 space 4. That was confusing. Was it 24, 204 or 2004? Merchants often struggle with this. The Egyptians used symbols to write 204. They combined symbols like this. That worked for record keeping, but imagine trying subtraction or division with it. And without a consistent placeholder, subtraction became guessing game. For 2 space 4, if you wanted to remove 20, were you subtracting from 24 to 04 or 2004? Even with Roman numbers like CCIV, there wasn't a simple formula either. Because of this, merchants and scholars often relied on abacus and counting boards. Written systems weren't designed for calculations. They were mostly for record keeping. This is where India changed everything. Indian mathematicians developed a decimal place value system and used dot or small circle as a symbol for nothing. Aryabhatta in 5th century laid the groundwork with positional notation, but it was Brahmagupta in 7th century who went further. He treated zero as a number and wrote down arithmetic rules for it. Now subtraction, borrowing and large calculations made sense. 7 plus 0 was 7. 7 minus 0 was 7. The rules had no exceptions. That consistency made math scalable. Merchants could now use formulas instead of case-by-case tricks. Few formulas were enough for lifetime of trades. Astronomers could calculate massive numbers when studying the stars. Zero wasn't a placeholder anymore. It was the number that made the system complete. But did the rest of the world embrace it right away? Not exactly. In India, zero spread quickly because it solved real problems. By 6th to 7th century, it was widely used in astronomy and commerce. The idea reached China and also appeared in Mayan system independently. In the Islamic world, zero became cipher. This traveled west, turned into cipher in Latin, and eventually zero in English. Scholars of Islamic Golden Age used it heavily in algebra and astronomy. However, Europe resisted. Between 12th and 16th century, merchants appreciated zero, but philosophers and theologians disliked it. Nothingness clashed with their worldview. Authorities also worried about forgery. Someone could inflate a number just by adding zeros. In 1299, Florence even restricted Arabic numbers, including zeros, in official records. But the pressure of trade, banking, and double-entry bookkeeping was too strong. By 16th century, Europe had adopted zero fully. From there, algebra, calculus, and modern science flourished. Once accepted, zero opened entirely new worlds. Negative numbers, binary computing, complex equation, all of them rely on zero. Today, zero is at the heart of computer, finance, engineering, and space exploration. From being nothing in the ancient world to being the foundation of everything, today zero proves that sometimes the most powerful ideas can come from nothing at all. If you like this little history lesson, don't zero me out on that like button and make sure to subscribe for more.